Hey everyone, welcome to the 12th session of Number Systems in playlist of Quantitative Aptitude for CAT and OMETs. So till the 11th session so far, we have completed around several topics of number systems, majorly IGP, sum of primes, and several others. Wait a minute. Looks like these folks are quite enthusiastic to learn, though the lecture has just started. Let me just get this call.
Hello, sir. Moreover, here. Sir, I understand we have covered several topics related to number systems, but I don't get the sense of where the topic of IGP would be useful apart from the selective few questions you have shown so far. Is there any other purpose to that topic?
Yeah. So I think it's quite a fair question since you may not have given the CAT or any other exams previously. You may find this topic to be quite redundant or to be very specific and it may not be asked several times. But the reason I had given this topic at the beginning was because a simple topic which is frequently asked in several of these exams, and that is finding the number of zeros in a number or factorial or even a product of given numbers. And specifically, we are talking about the number of zeros at the end of these strings. So, for example, let's say someone were to ask you how many zeros are there in 999 factorial, or even in 13 to 17 to 15 to 200. Obviously, from this product that I have given on screen, you can see that it has minimum of 5 zeros, but that's not all. There is definitely more than 5 zeros in that I can assure you, and I will also show you how we can find it. Since it has been asked, I think we will restructure our topic and make it circle around how to find number of zeros at end of any product or a factorial this time around. So let's get started. So let's understand first how a number ends up with a zero at its end. So it's a basic thing that for any number to have a zero at the end, it must be a multiple of 10. And we all know 10 itself is a multiple of 2 and 5. Now, I'm sure many of you folks already might have visioned that where this is going. So let's give you an example that we know 100 has two zeros at the end, simplest two digit, smallest number with two zeros at the end, that is. So what is there in 100? It is multiple of 10 into 10, which is again, if we prime factorize, 2 raised to 2 and 5 raised to 2. So we can conclude from this that to make a 10, you need a combo, or you can say a product of 2 and 5 in that. So with this knowledge, we will now proceed and conclude finally that for any number to determine the number of zeros at the end, we simply need to find the IGP of 10 in that. Or even more specifically, if it's a factorial or a big number, we can even make do with IGP of 5 sometimes. I will show you how. So let's do a few practice sets. Now, this is the question. I hope you guys pause the screen and try it yourself as I continue. So this is a multiplication of few numbers and you simply need to find the zero at the end. Now, many of you may find it funny for exams like SNAP and ZAT or several other exams where calculator is not allowed in the exam. In that case, some of like some of you may directly go for 300 or cannot be determined, but there's a logical way to here. Of course, in CAT, you can use calculator, so you can directly just multiply this number and find the answer. That would be simple as well. But let's see the non-calculator approach. So clearly here 63 does not have any multiples of 2 and 5 in it, so I will just skip it. 64, I know for a fact it's 2 raised to 6. 50 again, 25 2, so 5 raised to 2. 99 again does not have any factors of 2 or 5 either. 55 sure has a 5 and 44 has square of 2. So from here, all the powers that I can collect for 5 and 2, the highest power of 5 is 3 and highest power of 2 is 9. Now, obviously, to make a complete 10, 5 and 2 both are needed equally. So even though I may have surplus of 2's, I have no use for them. I will only be able to use 3. So yeah, IGP of 10 in this is 3. Quite simple, right? We didn't even need to check all of these. So that's how you can determine the number of zeros at the end without any calci in few competitive exams. And this was the reason why we were practicing how to find IGP of co-primes, because 10 is a co-prime. Now let's take another set. Find number of zeros at end of 999 factorial. The same example that I was talking about at the beginning. So here are your options. Now please go ahead, pause the video and try it yourself while I prepare the solution for you as well. So our standard practice of finding IGP is by continuously dividing the quotients that we get. So here we will be left with 246. Again, I always imply try to do mental maths in such simple additions by few tricks, like 199 plus 1, again 200, 200 plus 39 and 7, so 246. Very simple. Now IGP of 5 is 246 and IGP of 2 will definitely be more than this, because this is a factorial. I don't even need to think about it. It's definitely going to be greater than 246 and I don't have any use for them. So here you can clearly mark that IGP of 10 is 246 and move on ahead to the next. Again, another set. Again, this time it's a product and you have to find number of zeros at end of it. And these are your options. Now, first thing I will do, I know for a fact I am only needing 2 and 5 as the product. So I will just remove or ignore 89 and 73 in this product because they don't have any value to my solution anyways, in this case at least. So 66, clearly it contains 2, which is 6 into 11 and 6 itself has a power of 2. So 88 similarly, again 2 cube into 11, 200, 24, 225. These are the values that I'm getting from these rest of the numbers. And here I can clearly see the highest power of 5 is 4. And although again 2 has much greater power, no use here. So my IGP of 10 in this product is 4. So quite simple, right? What made it simpler is ignoring the number that does not have any 5 or 2 in its product or prime factorization, if I had to say. So with that said, let's move on to a bit more tricky question now. So I have a series from 13, 14, 15, all the way till 89. It's a product of all these numbers. Now it's a bit different from your factorial or product type questions. And obviously, even if you are given calculator in this case, it will be quite difficult to multiply all the numbers till 89, right? So let's approach it smart. Don't worry, just find for 89 first. Let's say if I had to find the IGP of 5 in 89, what will it be? It will be 20, as you can see. Now, if any of you have noticed it, that what is surplus in this? This is for 89 factorial, right? This IGP of 5 that we have found, it's for 89 factorial. But we are not exactly looking for the 89 factorial. What we are looking for is 89 factorial, but without 12 factorial. Isn't that one way to put it? What we have done here, we have just removed 1 into 2 into 3 all the way till into 11 into 12 from this series. That's what it is. So I just need to remove the surplus from this 20. So I will again do the same thing. What I will do, I will just find the IGP of 5 in 12. That's where my series is getting cut off, right? So that is 2. Now, for the given series from 13 till 89, what I need to do, I simply will subtract 20 minus 2. That was the surplus and I will be left with 18. And that's my answer. Well, quite tricky and interesting, right? So this is the case where even calculator won't be helping you guys out. But I hope you guys learned it well and enjoyed it as well. So with that said, let's do another question. Now again, a bit tricky, but I hope you guys can manage it. So here we have series from A till Z, all of them multiplied together, and we have been given values that A equal to 1 raised to 4, B equal to 2 raised to 5, Z equal to 26 raised to 29, all the way till there. Now, from it is very simple. First, I will identify the pattern here, that A is equal to 1, B is equal to 2. This is a simple pattern, right? We all know that A is the first alphabet, B is the second alphabet, and so on. And Z is the 26th alphabet. Now, the power is the key here. The power, you will notice that all are having power plus 3 in them, the number itself. Because you can notice in Z that 26 and 29. What's the difference? 3. So the power will always be the 3 greater than the number itself. So that's the main key pattern you have to look out for here. Now, again, in this whole setup, what I am more interested in is the powers of 5 and 2. Obviously, since it is a series of, like, similar to factorial, the occurrence of 2 and its multiple will be much more than 5, right? So I don't need to check for them because they will always be surplus, and I will always have sufficient 5 and its product. So what I will do, I will directly fine tune it and find the multiples of 5 which interest me. Like, I know for a fact that 5, 10, 15, 20, and 25, these are the numbers. As for their powers, I will just add 3 in all of them. Quite simple. So now here's the game. I will add all of these powers because they are giving me 5 every time. So from 5 raised to 8, I got the 8. 10 raised to 13, I got the 13. 15 raised to 18, I got 18, 23. Now you have to be careful because 25 does not come alone. It brings power of 5 but 2 times because it is a square. So there you need to remember to multiply that 29 by 2 because it is giving the power 2 times, right? And now if you add all of this up, you'll be left with 120, and that, my friends, is your answer. That IGP, or sorry, we are not bothered with IGP at all now, right? Are we are interested in finding the number of zeros at the end. So this number what we'll be getting will have 120 zeros at the end, and not to mention the numbers themselves at beginning apart from 0 would be there as well. So quite a big number we have got here. So again, let's solve another question. So how many zeros at end of product of 10, 20, 30, 40, all the way till 1000? So no need to fret it, just think logically. First thing I noticed was that all of these numbers are multiples of 10. So I can write it like this: 10 into 1, 10 into 2, 10 into 3, all the way till 10 into 100, right? Pretty simple. Now here where most of the folks make mistake, that while taking out the 10 common, they forget to add the power. Mind well, this is a multiplication series, not addition series. So if you are taking 10 common from 100 things, you have to account for those 110 multiples. That's why we have to remember to add the power of 100. And then obviously it's simple thing that the bracket will only have series of 100 factorial. That's why I said, just remember, it's not an addition. If it was addition, you could have simply taken 10 out common and then gotten 100 factorial, but this is multiplication. So you have got the power of 10 ready as 100. Now all you need to do is find power of 10 in 100 factorial and add it to what we already have. Quite simple, right? So 100 factorial, our usual stuff, just find the IGP of 5 in that. You will be left with 24, and you already have 100. So 100 plus 24, that will give you 124. So this product will have 124 zeros at the end. Again, a prime example where even calculator might not be able to help. Now, I think that's quite enough for today, since I think we are nearly about hitting our 15 minutes target for each session, but I still believe you guys need more practice. So this time I will just simply give 2 homework for you guys. Don't worry, we will solve it, but I hope you guys practice this on your own since they have a twist in them. If you are able to find it, good. because examiners will often play these tricks to play with your mechanical memory. Like whenever you see a question, you just know that okay, this series of tasks you need to do. That's not what they are expecting, right? So they play a few tricks here and there to make fun of that mechanical memory. So that's why I'm intentionally giving you these two questions. I hope you guys try to solve them and enjoy it. See you guys again in the next session. Thank you.